Hello everyone, this is Mike Rowland. This is the evolution of the Beast oscillator, and I've got it in an old uninterrupted power source. Here now is the Beast coil. I wanted to give you a quick update on the progress of this. Here it is, the big coil. See it there? And only this time I'm hooking it to this. This is a fan. See if you can see that. And I'll pull this out right quick. It goes in there. See the fan? Alright. And then there's a heat sink. And if you'll notice, it's a circular tubular shaped heat sink. And then I have the three parts on all four corners. See them there? These are the MJL 21194s. So we're going to get some gen mode, big time gen mode, and here's the top. Okay, now that's not what I come to show you today, although I love these oscillators. And I'm going to get that one, the triggers going on that. This is what I want to show you. See my big cap dump running? There's my big cap dump running, and you'll see the meter there going up and down, and like 60, 55, 60 volts to 30 in the 30s, 35. And here's the little box powering it. I should say big box. And here's my input. See that? It's not quite 5 amps. It's like 4 amps, fluctuating between 3 and 4 amps. You can see that. These lights seem to give a lots of glare sometimes. Okay, so what that is a variac, a 400 hertz type variac, aircraft variac, and below it, inside the box, is a same size toroidal. And then that goes over here to, well, I should say it goes here. See my coils? That's dryer coils. And that's a shrunk down box. That's my resistor. For those of you guys who understand me, this is my resistor. Get around here and show you the fan. See the fan I put on there? Just a 12 volt fan out of a PC power supply. That's my resistor. 6 ohm resistor coming from the power source, the variac. I can adjust it up and down. And it's at like 70. I go from 70 to 80 volts, and then and then I hurry up and dump it before that. So I'm dumping it like a few volts less, at least 10, 15 volts less than the source is maintaining. But I have an RC time constant, or a charge curve, to deal with this resistor. Now it doesn't get very warm at all. There's no heat evolution much out of it. I can put my hand on the wire. It's fine. It's only using half right now. I can parallel this and get a lot more power through it. But right now I'm burning it in. Instead of 6 ohms of resistance, I can go to 3, which gives me, I can go on up to 10 amps. On this little guy right here, I can go up to 10 amps on him, which is like a lot of power. I can go 90 volts, 10 amps. You know, I can get at least 700 to 800 watts of pulse energy charging through this cap dump. Now this cap dump has 6 parts. I don't know if you can see that very well. Let me get the light a bit better. See those little parts in there? There's a heatsink, and those MOSFETs are in there. There's 6 of them, and then a fan there on the top. So I got good airflow with just little puny fans, and you'll see them flashing along there. And a big stack of caps. Man, that whips these little batteries, these little 100 amp hour batteries, whips their back so quick. I gotta change batteries all the time. There it is. cap dumping along. Now what I had to do was, I've been doing this for a couple days, I had to take these pink wires, which are the triggers. You see these 6 triggers wires, and they all got 560 ohms of resistance on them, and they go to this wire nut right here. Then they go on over to this a little part here called wire wound resistor. See it there? And it turns out that if I don't put 850 ohms of resistance in between all of them now, not one but all of them in parallel with the 560s on the gate of the MOSFETs, see, because it goes up here to the other side, the wire nut, to the 5-5 timer and the opto, which is a crude setup for MOSFETs, they say. Of course, if it was 30 years ago, that'd be state of the art, right? So now I've got adjustable timing and adjustable cutoff right there. It lets me go up and down. Watch what happens when I adjust this one right here. Get my light just right. Get that glare off, you guys. Okay, I'm going to adjust this knob right here. I'm going to make it go higher. See it dump up higher, like 30 volts or 25. Or I can make it narrow it back down to where it's only dumping a few volts. See it there? And then I can adjust this one too, narrow it down. So that's kind of nice. Widen this out a little. Give me some more time there. Just a tiny bit. These are 10-turn pots, so I'm just moving it. Look at how small I'm moving it. We're talking just that much. It's already over or under. See, now we're talking quarter turn, if that, sometimes, or an eighth of a turn. So it's good to have these variable 10 turns to get you a more accurate adjustment. Now I'm trying to figure out a way to make all of these wires hang in there, protected in a box, put the resistor on there, cover it so it's not, somebody's not vulnerable when they walk up, you know, make it practical. Get all these wires and these fans hung up right. This fan right here just sitting here, and it's kicking some major pulses. I can't show you right now because I don't have a amp meter between the two batteries. Well, right now I'm coming down here and I'm going down this long red wire, and it's going clear across the room, and it's going over there on the other side of the room to that set of batteries over there, the automotive batteries converted to Elm. Remember, I use Elm. Always remember that. And then one more shot at the cap dump. Big cap dump. Lots of caps in there. You can't see them too well. I have shown other pictures of it. And automotive size battery cables, so there's no heating. Now there's only I'm only running about, let's see, if you go over here and look at the variac, there's a pointer on there, running about 70 some volts at, like, we'll say 3-4 amps, so you know, over 200 watts of power, and force feeding these batteries pulses. Now if you have just a regular battery charger and it's magnetized the electrons to the plates, it's far different than if you're, now look at this battery. This thing has been dead for months. I haven't charged those batteries, so I picked those because I can really kick them hard and they won't charge up, see? But they're going to be charged soon, the way this is going. This thing charges batteries. The reason I'm trying to really get it fast on these smaller batteries, 100 amp hour, is that I've got an 880 amp hour battery set I need to charge. So I want to really run up some at least 500-600 watts of power and power slam those batteries without burning up MOSFETs. That's what I'm trying to do. So this is paramount. You got to have a big resistor to slow down the charge time between pulses, or else this thing right here, you see it flickering up and down? That thing slams all the way over if there's no resistor in line with it. I mean, that makes your lights on your house flicker and everything. You'll have 2,000 watt surges if you're running 300-400 watts of power. So you must have a resistor in line with your cap bank to, you know, tame that animal down a little so that this needle won't hop so bad. And this needle is doing real, you know, I learned a lot from JOHN BEDINI using the SG oscillator, and I'm trying to move forward upward with more power. And people look at me like, well, you're still living in the Stone Ages, and I probably, to them, I am, but I do have a practical working unit that's, if you want to call it, almost cast iron. It's overrated. I got 3 times as many parts and much power handling as I need, but it works. And I'll ask some of you who are so intellectual about your MOSFETs and about your triggers and about all your fancy circuits, do you have one working? Is it still working? You know, I have so many, I've got plenty of devices with MOSFETs in them, and they're a piece of junk. To make a MOSFET driven device that's practical and industrial is difficult. JOHN BEDINI won't even use a MOSFET on his stuff, and I can understand why. These stupid things pop, you get varying quality, and I can see what John said now, using the MGL 21194s, that that they're more practical or more dependable, and they're not as sensitive or touchy, and they're a bigger part, and they only can handle less amps, so you have to gang up a lot more. I really do like the MGL 21194s. I think I'm going to throw all these MOSFETs out the window. Okay, so, but I wanted to try it, and it does work. I'm going to keep trying. I've got MOSFETs in my SG oscillator, but people say, well, you're putting too much resistance on the bases and you're making it like a dimmer. Well, that may be, but that's what's necessary. That's what's needed, and that's what works. In the beginning, I used deflection transistors, which had their own built-in resistor network, where they deflect. In other words, they go up and down, and they have their rise and fall times, but they're built-in safety where they have more resistance or something to protect that deflection transistor so it doesn't bottom out. See, what I was having was problems with this bottoming out, and you'll see, and it was going all the way over to 12 volts, well, not 12 volts, in this case 24 volts, and every time it would smash a junction, you know, one of my junctions, within a few minutes. If I drop the bomb on a battery all the way to the bottom where the battery is, you're going to smoke your parts. Now, I got lucky, if you want to put it that way, when I first started, because I used deflection transistors, and they already had built-in safety crossovers. Excuse me. I'm sorry, that would be called a voltage divider. Their built-in voltage dividers keep you from damaging them so easily. And they're already set up to not drop all the way to the bottom. That's what I want to say, which is what I needed with cap dumps. With MOSFETs, they want to fall flat on their face. So you gotta, like Mario said, you gotta put a resistor in there, like that resistor I showed you over there, and dial way up. Give yourself 1,000 or 2 ohms or 3,000 and start backing down. And I ended up, well, when I only used 3 MOSFETs on this board over here I'm showing you, the resistance was different than 4 or 5. I tried them one at a time. Some people say, oh, you only need 2 MOSFETs. So I tried it with different ones. And 6, I need 850. You need more resistance with more MOSFETs because the resistance continues to lower. So you need to, what I was having was a ticking noise, and that ticking was destroying all of my work. In the beginning, I was hooking up the batteries, and the direct to the cap bank was charging in reverse on those MOSFETs, was smoke all my work in a heartbeat. As soon as I'd hook it up, it'd be burned out. So I learned the hard way. Six FETs would be destroyed, and for $6 it was worth the learning experience. There you go. It's working now, and there's very slight heat evolution at a couple hundred watts, if any. And of course I got to run it up, and I got to pull this fan terminal to show you. At a couple hundred watts, it ain't nothing. It doesn't give you, I can put my hand in here in a few minutes and it's barely warm. It starts to elevate, get a little warm after maybe 10-20 minutes. And of course this resistor, let's see, yeah, that resistor is just warm to the touch. In other words, I can hold on to that wire right there, see that? At a couple hundred watts. So I'm not losing a lot of power with that resistor. I'm losing some, but if I were to use some kind of inverter or converter, I would lose the same amount, if not more, or the same, practically the same amount if it's done right. Maybe a little bit more conservative, but the resistor is an age-old practice to charge up caps with, and I use a cheap way, one that's very air-cooled and I can play with. It don't cost me nothing. I use a dryer element, and I've got a wire coming out of it, you'll see here, which splits it in half, and I can split it. I just put a copper band around the chromium wire and the extension wire that I bring out, and I can dial in my charge time with different resistances. Now in the beginning, I started with this idea. I had these industrial resistors from Motors. See it there? Now that thing it's got some almost like fins on it. I don't know if you can see that. They're flat bar, like corrugated paper. They're flat bar standing up on the roll, and they can handle 500 watts of power ganged up together in parallel like this. And I used that, and it got warm, but I couldn't cool it very well, so I went to the open core type of resistor like you're seeing here. That way I could easily cool it, wouldn't just be building up a bunch of heat when I want to charge up a large bank of caps like that. You know, I want to charge it up fast. You can see how fast it's charging. There's that glare again. Get that glare off you. See, it's like the blink of an eye there. A few seconds, and it's, if that, I mean half a second or something. Maybe a half a second or a third of a second it charges up. But if it's instantaneous, your lights are flashing. You'll see that needle peg over there if it's drawing enough power, and you'll blow all your breakers with that. So you need a resistor in line with your power source to charge all them caps, right? Once you get that settled and you're feeding the MOSFETs with an easy going current, a normal even supply. You won't trash your MOSFETs on the backside, and then as long as you don't run up your voltage. Now I ran up my voltage just for fun, huh guys, for kicks. I ran up my voltage over here to 100 volts one time. See that 100? And it didn't like that too well. I was running up about 1,000 watts or so. To do it I had to get 100 volts. I had the wrong resistor in there, and I was getting I had a bad solder joint or something, and then once I burned up one, of course I had abused that other set because I didn't have the triggers right. They all started popping one at a time. I just tested with 6 of them here this last time. Now I got a fresh set of 6 in there, and I know what to expect, and there's some of their limits, and I think it's good to set it like 50, 60, 70 volts and no higher, things like that. And then also I need soft starting. I need to walk this up slow when I start out, so I'm trying to figure out a way to make this power source automatic soft start so that I don't trash all my work in one stupid move. But you know, those are going to be additions, and I will do it. Sometimes people use relays for their soft start resistors in line with their caps and stuff like that. You could put in 50 ohms of resistance or 25, depending on how big your source is, and then the relay would drop out and be direct once it's charged. And because you don't want all those toroidal windings and those caps to have an instant surge. You'll have 400 volts climbing up your 5.5 timer. There it is. It's running on low right now, and I just turned these batteries on after they've been dead for a long time, and they're already at 29 volts. The 2 batteries were 18 volts to show you how dead they were, but like I say, they're Elm converted. They sit around, and they don't, you know, they're those dumb trolling boat batteries that aren't worth 2 cents you buy at Walmart. Perfect dummy load, right? There you go. That's my dummy load batteries taking a beating. And they're only 200 watts, but when I crank this thing up, it almost scares me to see how long it's going to go before something starts on fire or starts smoking. So we'll see. I want to get it up there to 1,000 watts, you know, to burn in. Should be able to handle that. Well, it's actually be rated more at that. I'm talking about at the input. What would be on the output with surges should be rated more like 10,000, I think, because I don't know how to figure it engineering wise. Well, I better shut up and get back to work here on different things. Just want to give you guys an update on what's going on and what I'm charging and the success story here. And also I got that oscillator that's next. I just finished this, sort of finished, not really finished, but getting a degree of success, and I still got to box it up and make it practical where it's not so dangerous, open face with 100 volt caps all charged up, and that thing is dangerous. So got to hang some fans and get some cords legit, and nice heavy duty cords, and get these gator clamps off here and these meters mounted somewhere and things like that. So it looks like the face of this thing is going to be coming out some, I don't know. But it is in a good box to start with, and I'll figure something out. Alright, thanks, and I hope you enjoyed the update. I'm sure FETs, a lot of you guys think that FETs are just wonderful, and I'm sure they work. It's just that I've been spoiled on different types of semiconductors, and I listen to guys who've been in the field for years that like JOHN BEDINI, saying that he won't use FETs on his oscillators and whatnot, and I'm beginning to see why. They are a teetotal pain, and you know where. Okay, that's it for now. Still learning.